Hey, welcome! Today we are diving deep into machine learning by breaking down a truly foundational lecture from the legend himself, Andrew Ng. So if you've ever wanted to really, truly get what this world-changing tech is all about, you are in the right place. Let's get into it.
Right off the bat, we're starting with a quote that just perfectly frames the scale of what we're talking about. When Andrew Ng says AI is the new electricity, he's not just trying to be clever. He's making this really profound historical comparison.
So what does that actually mean for us today, this analogy of AI being the new electricity? Let's really unpack that.
I mean, think about it for a second. 100 years ago, electricity didn't just create power companies. No, it completely upended manufacturing, transportation, communication, farming, literally everything. And AI, machine learning, it's doing the exact same thing right now. This isn't just for tech companies in Silicon Valley. It's this fundamental force that's about to reshape every single part of our economy and our lives.
Okay, so if AI is the new electricity, how does the machine actually, learn? This is where we get to the absolute core of what makes this technology so mind-blowing.
This really is the million-dollar question, isn't it? We hear this term thrown around constantly, but what does it really mean? What's at its heart?
And here it is. This is the classic definition from a pioneer in the field, Arthur Samuel. And the magic words here are, without being explicitly programmed. You see, instead of a programmer sitting down and writing millions of lines of code with hard-coded rules for every single possible scenario, we build algorithms that can figure things out on their own just by looking at data. And this story just perfectly illustrates the point. Decades ago, Arthur Samuel made this checkers program. But here's the kicker. He didn't program it with the best moves. He programmed it with the ability to learn by playing against itself over and over and over. And you know what happened? The program got so good, it could consistently beat Samuel himself. Just think about that. A machine surpassed its own creator at a specific task. That's the power we're talking about.
Now, this idea of learning isn't just one single thing. It's a huge field, but thankfully, we can break most of it down into three main approaches, or, as I like to think of them, three different flavors.
And here they are: supervised, unsupervised, and reinforcement learning. If you can get your head around these three, you've basically got the keys to understanding the whole field.
All right, let's start with the big one, the one that's driving most of the value in the world today, supervised learning. The best way to think about this is that you're the teacher. You give the algorithm a whole bunch of data that's already been labeled with the right answer. You give it an input, let's call it X, and the correct output, Y. The machine's entire job is just to figure out the mapping between the two.
And within this teacher model, there are really two main kinds of problems. First, you've got regression. That's where you're trying to predict a continuous number, like the price of a house. The price could be, any value in a range. Then you have classification. This is where you're predicting a specific category. Is this tumor malignant? Yes or no. Is this email spam or not spam? The answer has to be one of a few distinct options.
Okay, time to switch gears to our second flavor. With unsupervised learning, you're not the teacher anymore. There are no right answers provided. Instead, you just give the algorithm this massive, messy, unlabeled data set and pretty much say, go find something interesting in here. The machine has to discover its own patterns, its own structures, all by itself. You've definitely seen this in action. Think about Google News, right? How it automatically bundles thousands of articles about the very same event. That's unsupervised learning. Or imagine a company analyzing its customer data and suddenly discovering that its users fall into four totally distinct groups it never even knew existed before. That's the magic of finding structure in the chaos.
And that brings us to our third and final flavor, reinforcement learning. This one might be the most intuitive of all, because the best analogy is just training a pet, right? You don't give a dog a textbook on how to sit. You reward it with a treat for good behavior, and you discourage bad behavior. That's exactly it. The algorithm, or agent, just learns over time to take actions that get it the most rewards.
And this quote from Andrew Ng himself is it's perfect. It captures the idea with this amazing example from his own research. He wanted to teach an autonomous helicopter to do these incredibly complex acrobatic flips. So what did they do? They didn't program the flight path. They just set up a simulation where the algorithm got positive points for flying well and negative points for flying badly or crashing. Good helicopter, bad helicopter. And after tons of simulations, it figured out how to become an expert pilot all on its own.
So we have these incredibly powerful ways for machines to learn. But why does this matter to you right now? Because this stuff isn't just an academic exercise anymore, it's a full-blown revolution, and it's creating opportunities that are just unprecedented.
Let me be clear. The demand for people who get this stuff, who can actually apply these tools, is absolutely exploding. And crucially, it's not just in the tech world. Just like with electricity a century ago, every industry is waking up and realizing they need these skills to innovate, to grow, to simply stay competitive.
I mean, just look at how diverse these fields are. We are talking about everything from diagnosing diseases in healthcare and building self-driving cars to making manufacturing more efficient. It's even being used to analyze complex legal documents and to understand history and literature in new ways. The chance to do really exciting, meaningful work is popping up in almost every field you can imagine.
And the pace of this change, it's just staggering. As Nogue points out, the number of truly valuable, real-world machine learning projects that are happening today is way bigger than it was just 6 months ago. This field isn't just growing, it's accelerating like a rocket.
And you know, that really brings us to the final, most important takeaway from all of this. Machine learning is giving us the tools to tackle some of the world's biggest, most challenging, most meaningful problems. The technology is here, and it's getting easier to use every single day. So the real question isn't just, what can machine learning do? It's what meaningful problem are you going to solve with it?